We want to talk about take two. We want to talk about an important application of exponential functions, and this is exponential growth and decay. The reason this is important is there are many, many phenomena that in nature and of course in math that obey the law of exponential growth or decay. So let me give you roughly what an idea of what the law is. It says a quantity grows or decays exponentially if the passage of t units of time causes the quantity to be multiplied by some number b. I think it'll become more clear what I mean by that, but in general, if b is greater than 1, we say that we're experiencing exponential growth, and if b is between 0 and 1, we say that we're experiencing exponential decay. That sort of makes sense. If you imagine b is 2, if I say that every time, say, a minute passes, I multiply the number I have by 2, the quantity seems to be growing. On the other hand, if every time a minute passes, I multiply the amount of something that I have by 1/2, then it just keeps getting smaller and smaller and smaller, and we say the quantity is decaying. Let me just give you a couple of examples of things that you've probably seen or thought of that obey the law of exponential growth and decay, or decay rather. So, example one is if you start with 100 bacteria in a petri dish and the number of bacteria doubles every 30 minutes, we would say that this is an example of exponential growth. We'd say that b, that's the amount that you multiply the quantity by, is 2, and the time period t is 30 minutes. And second example is what we call radioactive decay. If the radioactivity of an atom cuts in half every 10 years, in other words, if it's producing, let's say, 10 millirems of radiation now, and in 10 years we expect it's only going to be producing 5 millirems of radiation, then we'd say that every 10 years its radioactivity cuts in half. That's the same thing as multiplying its radioactivity by 1/2 every 10 years. So here b equals 1/2, and we'd say the time period is 10 years. The third example is compound bank interest. The way that works is the bank says that it will pay you 5% of interest a year for letting your money sit in the bank. You may wonder why they would do that, and the answer is because they're renting the money from you so they can lend it to somebody else at a higher interest rate. That's how they make their money. So they pay you 5% a year in interest on your bank account. What that means is that every year you have 105% as much money in your account as you did last year just for letting it sit there, or the account multiplies its value by 1.05 every year. So in that case, b is equal to 1.05 and t is equal to 1 year. Just give you a little example of how that works in the context of a bank account. If we start with $1,000 now, then in 1 year, balance is equal to 1,000 times 1.05, or 1,050. Then in 2 years, balance is equal to what it was at the end of year 1, which is 1,050 times another 1.05, which equals 1102.50. The point is actually that the balance in year 2 is equal to the original $1,000 times 1.05, that gives you the first year, and then times 1.05 the second year. So that's 1,000 times 1.05 squared. This form of the answer actually gives you a little bit more of a sense of how exponential growth works. Every some period of time, we take the base and multiply it by itself, and then multiply that by the initial amount. So you'll actually see the law of exponential growth often written this way, where a, the amount of something, is equal to a0, the initial amount, that's like $1,000 in that example, times b to the kt, where t is the amount of time that's passed and k is the frequency with which the quantity multiplies by b. So in other words, if b was 2, k is the frequency with which the quantity doubles. So, and by the way, you'll often see it written in this form. A equals a0 times e to the kt. Let's actually use a different number. Let's say e to the mt or something like that, just to distinguish it from k. And there is no difference here in the two laws. The only thing is we're relying on the fact that b can always be written as e to the ln b. Remember that? Remember I told you that's really, really important in calculus to be able to recognize that that's true. So this is why you'll often see the law of exponential growth written in this equivalent form, even though it means the same thing as the first form. We'll just call that 1. We'll call that 2. In general, I use the first form when I can. So this is law of exponential growth and decay. This just depends on which way we're going, whether we're multiplying by greater than 1 or less than 1.